Hi, today we will be discussing on Thevenin theorem. Okay, so where is Thevenin theorem applied? So Thevenin theorem is mainly used to solve complex network. Okay, so for a complex network, in order to get the solution of that complex network, in order to determine the current and the voltage of the network, we can use Thevenin theorem. Okay, now consider a network which is connected to a load terminal. Okay, so let the terminals be A and B, and we are connecting this network to this load terminal. Now, what does this Thevenin theorem states that? It states like the network can be replaced by a voltage source which is connected in series with a Thevenin impedance. Okay, so the network which is connected to a load, the network can be replaced by a Thevenin voltage in series with a Thevenin impedance. Okay, now how will we determine the Thevenin voltage as well as Thevenin impedance? So the Thevenin voltage is the voltage across the load when the load is removed. Okay, so the network which is connected to the load, the voltage across the load when the load is removed, that voltage is called as the Thevenin voltage, and the Thevenin impedance or Thevenin resistance is the resistance that is seen from the load terminal. Okay, when all the sources are replaced by their internal resistance. Okay, now what is the how will we replace the sources by their internal resistance? A voltage source, an ideal voltage source, its internal resistance is 0, and an ideal current source is having internal resistance as infinity. So instead of voltage source, what we do is that we will replace it by a short circuit, and instead of current source, we will replace it by an open circuit. Okay, now for example, a network as shown above. See, in this network, we are having voltage source as well as current source. Now, how will we replace this network to its internal resistance? What we need to do is that we need to replace the voltage source by its internal resistance, that is nothing but 0, or we will short the voltage source. And what we need to do with the current source? The current source should be made as open. So all the voltage source like V1, V2 and V3. These are the three voltage sources in this network. So the voltage source V1, V2 and V3 may be replaced by a short circuit. And what about our current sources? We are having two current sources, I1 as well as I2. Am I right? So the current sources I1 and I2 should be replaced by as an open circuit. Okay, so that is shown here. We are representing the voltage source by short as well as current source by an open circuit. Okay, now let us so this is the equivalent circuit of our Thevenin theorem, in which we are connecting a network which is replaced by a Thevenin equivalent circuit. And what is the Thevenin equivalent circuit consist of? Thevenin equivalent circuit consists of a Thevenin voltage as well as Thevenin resistance which is connected in series. Now, how will we determine the Thevenin voltage? Thevenin voltage is the voltage across the load terminal when the load is removed. And what is the Thevenin resistance? Thevenin resistance is the resistance that is seen from the load terminal when all the sources are replaced by their internal resistance. Okay, now we will do a one problem numerical. So let us solve this network, which we need to determine the voltage across 2 ohm. Okay, so using Thevenin theorem, let us determine the voltage across 2 ohm as well as the current that is flowing through this 2 ohm resistance. So first of all, we have to determine which is our load. Okay, so since we need to determine the voltage across 2 ohm, or we need to determine the current that is passing through the 2 ohm resistor, we are assuming that 2 ohm is our load. Okay, now what we need to do is that, so this is our network which is connected to the 2 ohm load resistance. Okay, the network is connected to the 2 ohm load resistance. Now what we need to do? We need to replace this network by a Thevenin equivalent circuit. And the Thevenin equivalent circuit consists of two things. One is the Thevenin voltage, which is connected in series with the Thevenin resistance. Now, how will we determine the Thevenin voltage? As already we studied, the Thevenin voltage can be determined by removing the load and determine the voltage across our load terminal. Okay, so in order to determine the Thevenin voltage, what we need to do? We need to remove the 2 ohm resistor. Our load resistor is 2 ohm and we need to remove our 2 ohm resistor. Once we remove the 2 ohm resistor, we need to determine the voltage across that terminal. So that is the terminal A and B. Okay, so across the terminal A and B, we need to determine the voltage. Okay, so that is shown here. Okay, we have removed our load resistor, the 2 ohm resistor, and we need to determine the voltage across the terminal A and B. Okay, now how will we determine the voltage across the terminal A and B? For that, we can see that the voltage across terminal A and B is the same as voltage across 6 ohm. Am I right? The voltage across the terminal A and B is same as the voltage across the resistor 6 ohm. Now, so in order to determine the voltage across the 6 ohm resistance, we know as per our Ohm's law, P is equal to I into R. Okay, so we need to know the current passing through the 6 ohm resistor as well as the resistance. We already know it is 6 ohm. R is 6 ohm. Okay, resistance is 6 ohm. Now, what we need to determine? We need to determine the current that is flowing through the 6 ohm resistor. How will we determine the current? Current is nothing but voltage by the resistance. Am I right? So this is a closed path and these two resistance 12 ohm as well as 6 ohm, they are both in series connected. Okay, so the total resistance will be 12 plus 6, that is 18, and our total voltage is 30 volt. So how will we determine the current flowing through this path? That will be equal to V divided by R, that is 30 divided by 6 plus 12, 18. Okay, so 30 divided by 18 will give you the current flowing through 6 ohm resistor. Now what we need to determine? We need to determine the voltage across 6 ohm. So in order to determine the voltage across 6 ohm, we need to multiply this current with this resistance 6 ohm. Okay, so I am multiplying this current. 30 divided by 6 plus 12 is nothing but the current flowing through 6 ohm resistor. It is being multiplied by 6 ohm resistance. Okay, so we will get the voltage across the terminal of 6 ohm, that is 10 volt. See, that is the same as the voltage across terminal A and B. If you are closely analyzing the circuit, because there is no current flowing through 4 ohm, the load is removed, so that path is open. Okay, so the terminal A and B, voltage across the terminal A and B is same as the voltage across 6 ohm resistance. So what is AB? The voltage across terminal A and B is 10 volt. That is the voltage across the 6 ohm. So this is the Thevenin voltage. Thevenin voltage is the voltage across the load terminal when you remove the load. Okay, when you remove the load, what is the voltage across the load terminal? That is our Thevenin voltage. So we get the Thevenin voltage to be 10 volt. Now what we need to determine? Now we need to determine the Thevenin resistance. Okay, so we are replacing the network with a Thevenin voltage in series with Thevenin resistance. So we have already determined the Thevenin voltage. Now we have to find the Thevenin resistance. So in order to find the Thevenin resistance, again what we need to do? We need to open the load terminal. Okay, so we are removing the load. We are removing the load, and what we are doing? We are determining the resistance from the load terminal. Okay, we are determining the resistance from the load terminal provided all the sources are replaced by their internal resistance. So we are having only one source, that is the voltage source. So already we have studied voltage source. If you want to replace by internal resistance, what we need to do? We need to replace by a short. And if it is a current source, then we have to replace by a open circuit. Now here it is a voltage source, we have to replace it by a short. So we are replacing this voltage source by a short, and we are determining the impedance through the terminal A and B. Now if you look from the terminal A and B, you can see 12 ohm and 6 ohm are in parallel. Okay, 12 ohm resistance as well as 6 ohm resistance are in parallel. So what is the net value? 12 parallel 6, that is RA parallel RB will be equal to RA into RB divided by RA plus RB. So in order to get a 12 parallel 6, what we need to do? 12 into 6 divided by 12 plus 6. Now that is in series with the 4 ohm resistor. Okay, so this 12 parallel 6, that resultant value will be in series with our 4 ohm resistor. So that is why I am adding with the 4 ohm. So our total resistance, Thevenin resistance will be equal to 8 ohm. So we have determined now the Thevenin voltage as well as Thevenin resistance. Now what we can do? We can replace that entire circuit by a Thevenin voltage which is connected in series with Thevenin resistance. Now our Thevenin voltage we have already determined it as 10 volt. Our Thevenin resistance it is 8 ohm. So we can replace the network by this 10 volt and 8 ohm in series which is connected to our load 2 ohm. Okay, now it is very easy. The circuit which was very complex earlier became very easy. Okay, now we can easily determine the current flowing through 2 ohm. So by using the symbol Ohm's law, current equal to voltage by the total resistance. Our total voltage is 10 volt. Total resistance is 8 and 2 are in series. So the net resistance is 8 plus 2. So 10 divided by 8 plus 2 will give you a 1 ampere. Okay, so 1 ampere is the current that is flowing through our 2 ohm resistance. Now if you want to find Vx, what is Vx? Vx is nothing but the potential across this 2 ohm. So how will you find Vx? Vx is the voltage across 2 ohm. That is nothing but current flowing through 2 ohm into 2 ohm. Okay, what is the current that is flowing? 1 ampere current and the resistance is 2 ohm. So 1 into 2 will give you 2 volt. That is the voltage across our 2 ohm resistance. Okay, so with that we are able to solve a network very easily using Thevenin theorem. Thank you.